sum and difference formulas. Again, what we're gonna do is we're gonna go back to our formula sheet and we're gonna find those. Instead of me writing those down, so let me take you again to that website where you will see it. Trig formula sheet right over here. And this is the area that we'll be looking at, sum and difference formula. And we're going to do some problems dealing with sum and difference formulas. All right. So let's look at the first problem. Find the exact answer for cosine of 7 pi over 12. Well, if we use the table, we have that this table 0, pi over 6, pi over 4, pi over 3, and pi over 2 for sine and cosine. These are the angles that we work with, and then we also use all students takes classes, and then we use reference angle to figure out the exact answers. But 7 pi over 12 is not quite like that. So how do we go about finding the exact answer? Well, for that problem, we look at, can I combine two angles? Kind of looks like this. When I add them, I get 7 pi over 12. So what are the two special angles I could do that? The angles would be 3 pi over 12 plus 4 pi over 12. Because when I simplify that, this is actually what? Cosine of pi over 4 plus cosine of pi over 3. These are this special angle right over here. And I could use that cosine of sum formula, expand that, and get the exact answer. This actually gives me what? If this is your alpha, this is your beta, you get cosine of pi over 4, cosine of pi over 3, minus sine of pi over 4, sine of pi over 3. And I know what are the exact answer for each of them are. Cosine of pi over 4 is square root of 2 over 2. This is just 1/2. And then square root of 3. Square root of 2 over 2. And square root of 3 over 2. And I can simplify it even more. And no, you cannot combine this to term. Let's do another problem. Cosine of 15 degree. This is what we'll be looking at. So cosine of 15 degree, what are the two angles to get that? You'll get cosine of 45 minus 30. And we could expand that because it's a difference one. You get cosine of 45, cosine of 30, plus sine of 45, sine of 30. And we know the exact answer for each of them. Square root of 2 over 2 3 over 2 plus square root of 2 over 2, and then 1 half, which is just 4. Square root of 6 plus square root of 2. Now let's look at some sine one. Sine of 19 pi over 12. Let's be a little bit more systematic. This 19 pi over 12. What are the angles that you could add to get 19 pi over 12? Well, first one is 1 pi over 12 plus 18 pi over 12. Does that work? No, because pi over 12 is not our desired angle. Let's do the next one. 2 pi over 12 plus 17 pi over 12. That doesn't work because 17 pi over 12 is not our desired angle. Let's do the next one. 3 pi over 12 plus 16 pi over 12. This looks interesting. If I simplify that, I get pi over 4, and then I get 4 pi over 3. This works. Boom, right there. So I could rewrite it as sine of 3 pi over 12 plus 16 pi over 12. This is just sine of 4 pi over 3 plus pi over 4. And we could expand that. 4 pi over 3 cosine of pi over 4 plus cosine of 4 pi over 3 sine of pi over 4. And this is reference angle and so on. This just becomes negative root 3 over 2. Root 2 over 2 plus negative 1 half square root of 2 over 2. This becomes a what? Negative 6 over 4 minus root 2 over 4. So we could just simplify that. Okay, now we're going to make the problem a little bit more interesting. If I say sine of alpha is equal 4 over 5, and alpha is less than pi but greater than pi over 2. So it's in the second quadrant. And sine of beta is negative 2 root 5, and beta is in the third quadrant. Let's draw this out. What happens? Let's look. Let me use a different color. So this is alpha. So SOHCAHTOA, we use SOHCAHTOA again over here. SOHCAHTOA tells us this is opposite over hypotenuse. So this is the missing side. But because this is the negative x-axis, it's going to be negative. So we got our alpha angle done. Let's do the beta angle. Beta is opposite. Note I put negative 2 because y-axis is opposite over here, root 5. So this side is going to be negative 1 because when we use a squared plus b squared equals c squared, in this case a squared plus negative 2 squared equal square root of 5 squared, then a is 1. But because this is on the left side of it, it's going to be negative. So we found out a angle A and angle B, all our desired triangles. So if I give you a question like, what is cosine of alpha? It's super easy. We look at this. Alpha is adjacent over hypotenuse, -3/5. If I say cosine of beta, this is easy. Adjacent, -1/√5. Boom, that's super easy. And what if I say, what is cosine of alpha plus beta? Well, you can't add them, but we can expand it, which gives us cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And we know what sine of alpha, cosine of alpha, cosine of beta, and sine of alpha, sine of beta, what they are. So now we could easily just plug it in. Cosine of alpha is -3/5, -√5/5, minus 4/5 times -2 root. Let me rationalize the denominator so it kind of looks nice because we get the common denominator. And when I do that, this becomes what? 3√5/25 plus 8√5/25. And I could add them. I get 11√5/25. Now, what if I ask you what's sine of alpha plus beta? We can expand it. Sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. Sine of alpha is 4/5. -√5/5. Oh, I think that's cosine of beta. Let me make sure. Oh yeah, because I wrote it as this, and when you rationalize that, it becomes -√5/5. That's how I got that. If you have any question, then plus -3/5 times 2√5/5. So I get -4√5/25 plus 6√5/25. I just get 2√5/25. Now, what if I give you a question like this? Find the exact value cosine of cosine inverse of √2/3 plus sine inverse of -3/4. Now treat this problem as cosine of alpha plus beta. So if I do that, then I get cosine inverse of 2/3 equals alpha, and sine inverse of -3/4 equals beta. Now, this tells you what? Alpha is in the first quadrant. because we're looking at a cosine inverse. Cosine inverse lives in the first and the second quadrant. Since it's positive, we're looking at the first quadrant. This is your alpha. And then this eventually means is what? Cosine of alpha equals 2 over 3. So what is this? Adjacent over hypotenuse. So what's this missing side? 3 squared minus 2 squared is equal your missing side. We'll call it A. So 9 minus 4. So you get square root of 5. This tells you what? Sine of beta is negative 3 over 4. And we're looking at sine inverse. So what quadrant are we looking at? Fourth quadrant. Because sine inverse lives in first and the fourth quadrant. And it's opposite over hypotenuse. And y value is negative. So negative 3 over 4. So what's the missing side over here? 16 minus 9 gives you 7. So and then we do the square root of that. So the missing side is going to be square root of 7, and it's going to be positive because x-axis is positive on this one. Boom. So we got these two special angles right over here and right over here, this triangle. Now we could do this problem easily. So if I expand this out, cosine of alpha, cosine of beta, minus sine of alpha times sine of beta. And we could use this triangle to figure this out. So cosine of alpha is going to be 2/3. And cosine of beta is going to be square root of 7 over 4. Then minus sine of alpha is going to be square root of 5 over 2. And times sine of beta is going to be negative 3 over 4. And we could simplify this. We get 2 over 7, 12. Wait, yeah. Did I make a mistake somewhere? Oh, square root of, it's going to be 3 right there, sorry. And then this is going to be positive root 5 over 12. And I could just combine that. That was a hard one, guys. So let's look at another problem. Solve the trig equation. So I have sine of theta plus cosine of theta equal 1. And I want to solve for theta. And theta is between 0 to 2 pi. So how do we go about doing that? Well, we can't do anything. We could only deal with if I have sine square or cosine square. So if I square both sides, I get sine square of theta plus 2 sine of theta cosine of theta plus cosine square of theta equal 1. Well, we know sine square of theta plus cosine square of theta equal theta plus 2 sine of theta cosine of theta equal 1. But we know what this is. This is just 1 plus 2 sine of theta cosine of theta equal 1. And we could simplify that. This just becomes 2 sine of theta cosine of theta equal 1. According to that, the formula should, what do we know about 2 sine of theta, cosine of theta? Two sine, oh, sorry, this is just 0 because you subtract that. 2 sine of theta, cosine of theta is actually sine of 2 theta. That equals 0. So you got to ask yourself, for what value of theta you get 0 over here? For 0 to 2 pi. That's only possible 2 theta equals 0. And then if you get theta by itself, just divide it by 0 and you get that. And that's your answer. Okay, this will conclude today's lecture. Email me if you have any question. I'll be by the computer. Thank you.